Today we are going to start the next section. This section is about slope and rate of change. Okay, so again, hopefully this rings some bells from Algebra 1 and Algebra 2. Okay, this is something we've talked about for a long time. We're just going to cover it again in this class. All right. So first, okay, let's talk about average rate of change. Okay, apply this to some real life situations. So, in our example here, well, I guess we could start up at the top, cut that off with the definition of rate of change. Okay? It's just a ratio that compares how much two quantities are changing, okay, relative to each other. So, a lot of times we're using time to compare how quickly things are changing, right? But we could be using some other measure. In this first example, okay, we're measuring the change in elevation of the sun in degrees versus time. All right, so if you remember thinking about slope, okay, slope is always the change in the y values divided by the change in the x values, okay, or the change in the the change in the dependent variable over the change in the independent variable. In terms of a table, and if we're given information like this in a table, right, it's just going to be the total change in elevation of the sun. Right? So if we're looking at degrees, right, we're going to take our final data point and our first data point. That's going to be the total change. So to figure that out, we're going to take our last data point of 84 and subtract 6 from that, our first data point. And that's going to get us how much it's changed. What? So if I start at a position of 2 feet and I walk to a position of 11 feet, how far have I gone? 9 feet, right?
I was getting there.
First, my final position minus my initial position. That's the idea here, right? So we're just taking our final position minus our initial position to get how much we've changed, okay? Then we also want to do that over the change in time, right? So if it's 11 a.m. to 7 a.m., I can subtract those values. 11 minus 7 is 4.
Yes. What
about 84 minus 6?
78.
78?
Yes.
Right?
Bam! Wait, like right now?
No. Okay, so this is our rate of change. Okay, now if we're talking about something in a real life situation, okay, we're probably interested in how much this is changing per hour. Right? We're not going to say, well, it changes 78 degrees every 4 hours. Right? It might make a little bit more sense to actually divide this. Right? So if you have a calculator, what is 78 divided by 4? 19.5. Right? So what I can say is my rate of change here is 19.5 degrees per hour. Okay, my rate of change is 19.5 degrees per hour. Right? That's what we're approximating. Right? The average rate of change. So we're using our idea of slope. Rise over run, or change in y or change in x, to apply to a real life situation. Okay. Questions on that idea? All right. Do we want to try another one together?
Yeah.
Yeah. So let's jump down to number 1 here.
Yeah, I still don't know. Yeah, I still don't know.
Okay. So here we've got the number of people in the auditorium, okay, changing based on the time. Okay, so what would be the best way to set this up? Right? Am I going to first, which is going to go on top, which is going to go on bottom? Am I going to have people per hour, or people per minute, or minute per people? Which would make more sense? People per minute, right? So which one should go on top? People. Okay? So to figure that out, to figure out how many, or the change in people, we take our final number of people minus our initial number of people. So 151 minus 26. Okay? That's going to then go over the change in time. Now, when it's set up like this, right, 740 and 715.
It's 215.
Yeah, exactly. That's the best way to write this is going to just be 40 minus 15. That will be 25. Okay. What about 151 minus 26?
I got that one. Oh, wait. It was 1.5. Bam!
Look at that mental math.
Laying it down.
Okay.
All the water fast.
So my slope, right, is 125 over 25. Or if I actually do that division, how many people per minute? 5 people per minute. Okay. So on average, every minute, 5 more people are coming into the auditorium. Feel okay with these? All right. Then we're going to take a couple minutes and you guys try a couple of these here on your own.
The guy in the village, oh my god, he barely fit my car. I feel bad. He like had to see all the way back. It's like,
Was
he tall?
Alright, take a look. Let's take a look
Oh
at the answers up here. Okay, see how you did. And if there's any that we want to talk about in a little bit more detail, we can do that here. Straightforward.
I don't remember doing it like this though.
Does it make sense?
Yeah, it's actually easier.
So any questions?
Wow.
The first time when I tried to do this, I had the hardest time because like I didn't know we had to switch the thing around for the first problem.
Oh, yeah.
Like threw me off.
Yeah, you just kind of have to use common sense. Like what makes more sense? It makes more sense for people per minute rather than minutes per people. Something like that. All right. If there are no questions, then let's go ahead and flip over to the back. Okay, and let's talk about a little bit more traditional slope. Okay, this might be a little bit more ingrained into your head. That's slope-intercept formula line. Okay, so if we've got 2 coordinate points, and we want to find the slope between them, and it's really similar to what we were just doing. Okay, we're just going to be using defined points on a graph. And so if I've got 2 points, the slope, which we use an M as our slope, right? That signifies slope. It's still change in y over change in x. But if we want a formula for that, we're going to use y2 minus y1 over x2 minus x1. Okay, now, what that means, okay, if I look at my 2 coordinate points, I can say, well, this first one is x1, y1. And the second one is x2, y2. Okay, it's a good idea to label your points like that. Okay, say, well, this first one's x1, y1, the second one's x2, y2. Now remember that every single coordinate point has an x and a y. Okay, some people get confused and say, well, I'm going to make this one x1 and this one x2. That's not correct. Okay, every single point has to have an x and a y. So I can label my first point x1, y1, the second one x2, y2. And x is always first, correct. So if I plug those values into my formula here, okay, y2 minus y1, I'm going to have 5 minus negative 1 over negative 4 minus 2. Okay? This is another important point that leads to common mistakes. Right? Make sure that here in the numerator, we have a double negative. We got our subtraction sign, but then I'm subtracting a negative number. Okay, don't lose that second negative sign. Right, we're always subtracting, but in this case, I'm subtracting a negative number. So this ends up being a double negative. So in my numerator, what's 5 minus negative 1? 6, right? It's the same as 5 plus 1. So this would be 6. What's negative 4 minus 2? Negative 6.
Oh.
Right? So if you think about on a number line, right, if we're at negative 4 and I go 2 further to the left, I'll be at negative 6. Now, when we're finding slope in this format, we always want to leave it as a fraction. Okay? In our table examples there, when we were talking about real life things, we got a decimal. Right? It makes more sense to talk about a decimal or a whole number when we're talking about a real life situation. But if we want to talk about slope on a graph, it makes sense to leave it as a fraction. So when we get this fraction, we want to reduce it as far as possible. So how can I reduce 6 over negative 6? It'll just be negative 1. Right? I'm actually going to leave it as a fraction. So I'm going to leave it as negative 1 over 1. Right? You okay with slope like that? Yeah? Okay. Let's take a couple of minutes then, okay, and try a few of these. Okay, we'll come back to the graph example here. Okay, but for right now, let's jump down to the exercises and try a couple of these. Okay, we'll say we're going to spend 7 minutes on it. Okay, so try to get as many done as you can in 7 minutes. You're probably not going to get through all 9 of them. That's okay. That's fine. Okay? But try to get through as many of these as you can in the next 7 minutes. All right.
I should have stitches. I just wanted to needle it in the like how you can with my finger. Because like it was just like a little bit of stuff. And yeah, but it was bad. I was looking at it.
For people under 21. That's why I tried telling him, and he wanted to call me disrespectful. I'm like, no, that's.
All right, let's take a look at our answers here. Okay, now on a couple of these, they wrote them as whole numbers, but I would prefer if you wrote them over 1 and kept them as a fraction, right? So 3 over 1, 2 over 1, negative 2 over 1. Okay. So check your answers up here. Are there any that we want to take a look at in any more detail?
4.
4? Okay. So on number 4, if I label my coordinates, x1, y1, x2, y2, and then plug them in. So my y2 is 3, my y1 is negative 3, 3, so I'll have 3 minus negative 3 over negative 4 minus 5. So 3 minus negative 3 is the same as 3 plus 3. That'll be 6 plus 3. And then negative 4 minus 5 would be negative 9. If I reduce this then, both of these are divisible by 3. So 6 divided by 3 is 2. Negative 9 divided by 3 is negative 3. So that's how we get negative 2/3. Okay? And I guess one other thing to point out, if we just have one value negative, right, either the denominator is negative or the numerator is negative, we can just pull that negative sign out front. Right? We don't have to keep it with the numerator or denominator.
We just have to get a negative side. But then just keep positive.
Yeah. We'll talk about that. Any of these other ones that we want to take a look at?
7?
7?
Yeah.
Alright. So on number 7, do the same thing here. Label x1, y1, x2, y2. So y2 minus y1 would be 3 minus negative 2 over x2 minus x1, so 3 minus 7. And so 3 minus negative 2.
Oh my gosh.
Bless you.
Same as 3 plus 2, so that'll be 5. 3 minus 7 would be negative 4. And we can't reduce that, so that's the final answer. Okay, you okay with that?
Yeah. Sneeze no.
Yes.
Yes, you bought.
I'll be there in a second after we take a look at slope from a graph. Okay, so last idea. Let's jump back up to example 2 here.
Don't say
Come back up.
no.
Okay, finding slope from a graph. And I guess I'm going to scroll up just a little bit and add on to this here. Okay, so we have one more definition of slope. Right? From a graph, right, you talked about slope is rise over run,
Or Y over.
or change in y over change in x. Right? So if I want to find slope from a graph, I want to pick out 2 points that I know for sure. I know the coordinates of. So they've done that for us here in this example. Right? These 2 points right here, I know for sure. Now, I could, excuse me, I could label these points and say, well, this is 3, negative 3, this is 1, negative 2, and then go through the same process that we did in example 1. Okay, that'll work, but there's an easier way of doing it if we have a graph. Okay, if we have a graph, we can just use this rise over run idea and say, well, if I start at my leftmost point and go to my rightmost point that I've chosen, I first look at the rise. Okay, rise is how far we change in the y direction. So going from this point to this point, I change negative 1 in the y direction. Right? I go down 1. So I'm going from this point to this point. Then I go to the right 2. Okay? Change in y over change in x. So my slope is just negative 1 over 2. Okay? Change in y over change in x. Okay, now if you're getting confused with the negative signs, okay, you can always just say, well, I changed 1 in the y direction, I changed 2 in the x direction, then is my line going up or down? Well, if it's going up, your slope should be positive. If it's going down, your slope should be negative. Okay? So make sure that you double check using that common sense, right? If you look at your line and say, well, it's going down, my slope better be negative, right? If it's going up, my slope better be positive. So just double check yourself there when you're doing these. Okay? Questions on that? That's right. Okay. Then we've got 8 minutes left. Let's go ahead and jump down to the bottom and find slopes for these graphs here.
You check mine.
Sure.
I just want to make sure I don't think that.
Well, there's an easy way to double check, right? I'm not putting them up yet.
They look like they're going up.
Back of the knee. That's crazy.
All right. Take a look at the answers up here.
So
All right.
bad.
See how we did. Are there any that we want to take a closer look at? 13? Yeah, so this one. This one is a little bit difficult to find 2 points that we know for sure. Right? We do have to be very careful when we're choosing those points. Okay, so if I'm looking along here, it looks like this is an exact point right here. And I would probably say this one right here. Okay, none of those other points, that doesn't go through, right? So we have to be careful in choosing exact coordinate points here. So once we do that, then we look at how far we change in the y and how far we change in the x. So from this point all the way up to here, I go up 1, 2, 3, 4, 5, 6, 7, and then I go over 1, 2, 3, 4, 5. So my slope, my rise is 7, my run is 5, and my line is going up. So my final answer should be positive. Okay, so positive 7 over 5.
It's not that hard.
It's not too bad.
I feel like I'm gonna forget it.